All right, so today we have area of a triangle when it is not a right triangle. If it's a right triangle, then you can just use 1/2 of the base times the height, and you have your answer. But that is not the case when you have the area of a non-right triangle. But there is a formula that you can use, which is shown here. It's 1/2. You take one side times another side times the sine of the included angle. So these three formulas here are just depending on what included angle you have. So notice if you have angle C right here as the included, then its sides are A and B. For angle B, the sides are C and A. And then notice if you're looking at angle A, if that's the included angle, then your sides are C and B. So it just depends on what information you're given, but you have to have an included angle in order to use this formula. So let's do some examples. All right, the directions again are important. Answer the following if you're given an angle that you're supposed to know, meaning it is 30, 45, 60, 90, 135, 120, 225. Any of those angles, those are angles on your unit circle, and you would be able to do those without a calculator. So there's going to be a little mix match of those. I have labeled on there whether to use a calculator or not so that you do not have to guess. If drawing a picture is helpful to you, then do that. You are not required to draw a picture, but again, if you struggle a little bit, pictures are always helpful. So find the area of a triangle with one side of 12. So here's 12. Another side of 7. There's 7. And an included angle of 135 degrees, which, let's fix my 7. So here's 7. There's 135 degrees. So there is a triangle. The area of that triangle is going to be 1/2 times one side times another side times the sine of the included angle, which it told us was 135 degrees. 135 degrees is an angle that is on our unit circle. So area equals 1/2 of 12 is 6 times 7, so 42, times the sine of 135 degrees. So unit circle, here's 135 degrees, that's the point, negative root 2 over 2, comma, root 2 over 2. So the sine of 135 is root 2 over 2. So the area of this triangle is 21 root 2. We are given units. Area is squared. So 21 root 2 inches squared. Do not forget the squared when you are writing your area. If there were no units given, then I do not care if you put U squared or not, but you do, when inches or a unit is given, you must put that unit squared. All right, here it just gives you a picture. Again, it's an angle that we know. So the area of this triangle, 1/2 times one side times the other side times the sine of the included angle. This is a formula you will have to memorize. You will not be given formulas on tests and quizzes. So our area is 1/2 of 6 is 3 times 10 is 30 times the sine of 60 degrees. Again, your unit circle. Here's 60 degrees up here. That's the point 1/2, comma, root 3 over 2. So sine is going to be root 3 over 2. So the area of this is 15 root 3. There are no units, so you can say that, or you can say 15 root 3 U squared if you want. Me, Miss John, personally, does not matter if you leave it blank or put U squared or units squared on a problem where units are not given. But be sure to follow your teacher's direction on that unit. All right, so notice this one's a calculator problem. This one we're going to work backwards. It says the area of triangle PQR is 15. It gives you two sides. You want to find all possible measures of angle R. So, unlike 3.1 and 3.2, when we found the principal value, this is not asking for principal value. It's asking for all the possible values. So there are more than one answer. We're not trying to trick you. If it says find all possible, that means there's going to be more than one. So read the problem and pay attention to the words. All right, so first, if we want to draw a triangle, so I could draw a triangle like this. Here's 5, here's 10. So 5 is going to be across from P, 10 is going to be across from Q, R is what's missing. But I could have drawn the triangle like this. 5, 10, where this is Q, this is P, and this is R. So notice right there, see the two different possible angles I could have. I don't know whether it's an acute or obtuse angle. What I do know is those two angles are going to add up to be 180 degrees. If I drew those together, think about this. So here, if this was 10 and that was 10, and this was 5, I can draw a triangle here, or I can draw a triangle here. So notice these two angles right here are going to add up to be 180 degrees. We don't know which triangle we have. So area is 15, 1/2. We know one side is 5, another side is 10, times the sine of the two angles we're trying to find. The calculator is only going to give us the principal value. To find the other value, we just subtract it from 180. So here we have 15 equals 25 sine R. Divide both sides by 25. You can simplify or not. It's really up to you. You're going to put it in the calculator. So if we wanted to simplify that, divide them both by 5. We get 3/5 equals sine of R. Anytime you are finding an angle, you use the inverse. Finding an angle, you use the inverse. Say that again. Anytime you are finding an angle, you are going to use the inverse. And we're dealing with this triangle right here, so we're going to be in degree mode. So make sure your calculator is in degree mode. And what we're going to type in the calculator, so we need the inverse sine of the side, and that's going to give us one of the angles. So second sine 3 divided by 5, or 15 over 25, equals. That's going to give us one of the sides. So that is this possible angle right up here, this acute angle. So our one answer is 36.870 degrees. There's one possible answer. Or we take that answer, subtract it from 180, and we get our other possible answer. That's the acute angle, 143.13 degrees. So there are your two possible angles. Again, the question said find all possible measures, so that's what we did of R. And it could be 36 or 143, depending on which triangle we have. We just don't know. All right, and then our last one talks about a regular octagon. That's a geometry word. Regular means all sides are the same. Octagon, 8 sides. So it's inscribed in a unit circle. If it's inscribed in, that means it's inside. You have to know what that word means. Again, geometry review. You have to remember all of that stuff from geometry. So we don't want to find all those little parts. What we want to do is find the circle. Scratch that. We want to find one of the triangles that is created in this octagon, and then multiply it by however many triangles there are. Because, again, we're using the area of a triangle. So there's one triangle. 2 triangles, 3, 4, 5, 6, 7, and then 8. So there are 8 triangles. Each, since it's regular, that means that each of those angles is the same. So 360 degrees divided by 8 is 45 degrees. So if I bring this one triangle out, this is 45 degrees. It said it was a unit circle, so this side is 1, this side is 1. So the area of that one triangle is 1/2 times 1 times 1 times the sine of the included angle. So again, it's a number on our unit circle, so we don't use a calculator. So A equals 1/2 times sine of 45, root 2 over 2, which is equal to root 2 over 4. So that's the area of one triangle. But we have 8 triangles, so 8 times root 2 over 4. 8 divided by 4 is 2. 2 root 2 is our area. There were no units given, so me, Mrs. John, I do not care if you put u squared or unit squared, but be sure to ask your teacher. If your teacher requires you to put u squared or unit squared, they can do that. So you must follow what your teacher tells you to do.